think girls.
थोड़ा नहीं पूरा issue है पूरा नहीं girls के लिए कोई girls could be managed actually मतलब we give priority to them some family accommodations are there so some are arranged that way but generally it's priority actually I mean to say it's a problem but it can be मतलब that way.
Sir, are there any chances of offline classes to start anytime soon? Sir, at least for the MTech or the PhD, as we also have to work on our projects from next time.
Yeah, that we'll talk later. So here we were talking some heat transfer in the spherical coordinate. So this what you have here. This is a standard equation of heat transfer in the spherical coordinate considering r, theta, and phi directions with generation within the material itself and with means temperature with the accumulation term also, right? So we want to simplify this also for a first primary level type of the problem. So for that we have neglected for time being generation term and steady state operation and heat transfer only, radial direction only. So keeping in those constraint on this actually, so you will left with only first term, and for that you are getting this actually, and your partial derivative would convert it to total derivative because r is the temperature is the only function of distance only now. Keeping constant thermal conductivity, so again the k can be taken out from the differential sign there. So you will leave with this equation, and this you can solve this means analytically also. It means integrate it two times, right? And that's also can be solved analytically. And from the numerical method there, you can differentiate that one and you will get r square d square t upon dr square plus 2r dt upon dr equal to 0. And then discretize it using your finite difference formulations using the central the difference expression there. Substitute that, and if you will rearrange it, you are getting this is your governing equations. So in this, you keep on changing your I, you can generate your number of equations actually. So as many number of the difference point you need, those many equations could be generated. So let's say I equal to 1. So, okay. So first we want to generate it for a temperature boundary conditions. So first you have, let's say, temperature boundary conditions at r equal to 0. Your temperature at T0 and r equal to outside 1. So Rn plus 1 I gave. So temperature is Tn plus 1. And then you generate the matrix there and you can rearrange it in this particular format. So for that, let's say you are putting at I equal to 1. So if you will put that here, so your T naught is known now because you know the temperature boundary conditions. So this is your first boundary condition actually. So this would be on your right hand side. Rest of the part is your left hand side because these are unknowns. T1 and T2 are unknown actually. Then keep on changing your I 1, 2, 3, 4, 5, 6 because this will give you always a trend that how my matrix is getting changed. So just putting 1 or 2 doesn't help sometimes. So it's better to put at least 4, 5 equations so that you can able to identify what is the trend actually. Okay, so this is always helpful in the writing a good program. So once you have generated that, then you have at the last point there at I equal to n. So you got this, and this is your Tn plus 1, which is your last boundary temperature. And then you can rearrange it in terms of matrix, right?
Yes.
Yes, sir.
So now this is your matrix for this particular case. So then you have a central actually you have diagonal that is minus 2 r square by c. Then you have right side diagonal one, that r1 square upon c upon plus r1 plus c, and this side is with the minus sign here. So this is again same as you did, I think, in terms of the cylinder. Only thing, I think you are getting one term extra there, that r1 by c. Correct or not?
Yes, so we
Yes.
get the R1 term extra.
Okay. So one term is extra there. So this can be actually by changing slight change in previous program, you can also generate this particular matrix. This is your boundary condition matrix. So these are your unknown temperatures, and this is your boundary condition one. So you wrote there. And programming can be written the same way as you have previous one. So these are the same commands. So you have at any I, you want to just generate. This is your main diagonal. So you keep on changing I, it should not change. Only this is your first boundary. So you have deliberately put here at I1 here, I comma 1. So deliberately means it will calculate only first one here. If you want to put the last one here, so you can put I comma n here. So where you have I comma n here is n comma 1 practically. So if you have this also, you will calculate your last boundary. This is your last boundary. Correct? The last
Yes.
boundary, your Tn plus 1. So that can be generated. In between, body is same. So you want to generate this one. This is your left diagonal. This is your right diagonal. So by putting that, so you will get your matrix generated. This is again by putting your MATLAB code there. You have problem statement. I will read here first actually. So what you have. So problem statement is this, that you have a spherical container of the radius r naught equal to 8 centimeter. Then you have Rn plus 1 is the 16. So practically you have here Ri, and this is your means R1 R2 actually. Thermal conductivity is given to you, and temperature at both the boundaries are given 280 degrees Celsius. And you are maintaining some temperature by chemical, the reaction inside the sphere actually, not within the material. You have inside the hollow sphere which is maintaining the temperature, not anything injected inside the material of the sphere actually. So these are conditions. So for that, this is the program actually I wrote here. So it's the same way which you have the generated previously. So then you wrote actually this program. So this may help you actually. You can write your own. Because you already wrote actually, so you can write your. This may also help you. So once you have this, then this is your just a temperature calculation is over from here. So you got here. So then this is your temperature matrix. You want to add boundary condition there. This is what you have calculated from 1 to n. This is last boundary temperature. So this is now a complete your temperature vector actually. Temperature vector, or you can say column. Radius also, you want to add first radius, last radius, and in between point there. So you have complete now a full set. Then you plot it there, temperature versus the radius there. So you plotted this one. Then after that, you are calculating your heat transfer rate. How is it changing from each difference point? And then you are calculating your analytical solution here actually. So analytical solution is possible for this case. So once you have plotted this, and these are again same commands here. This is just a copy and paste from the previous one. Only thing you are just changing your variable name. Rest are same. Okay. So you should try these commands today actually.
Yes, sir.
So Once you have this, so after that, this is your analytical temperature expression for the case of a sphere. This is what you will get it for temperature boundary condition, and this is your heat transfer rate here, and then you calculate error and all this. So once you will do that, so this is what you will get here. So you will get temperature here, and then you are calculating absolute error here at this particular point. Okay.
Yes, sir.
So once you completed this part here, so I have just shown your temperature, your absolute error. You can also calculate heat transfer rate. So heat transfer rate means in case of steady state, it should not change. So that's what it is not being calculated along the radius actually. So this remain constant. So that's why it's not being calculated here. Fine.
Yes, sir.
Anything in between you want to ask for that, because it's just an extension of the previous one.
It's fine, sir.
Okay, so next